Today we will continue our conversation on the operation of addition by looking at some basic properties of addition. With this knowledge, complicated-looking problems may become much simpler to calculate. We will also use these properties over and over again to solve algebra problems. So let's get started. We will start with the commutative property of addition. Addition is commutative, which means that we can reverse the order of two numbers being added without changing the sum. So a plus b is equal to b plus a. When I'm counting dogs, if I start with 2 dogs and then add another 3 dogs, my total will be 5 dogs. And that's the same as if I started with 3 dogs and then added 2 more. The total is still 5. Order does not matter. Again, this applies only to addition by itself. No other operations are present. Next is the associative property of addition. Addition is associative. This means that when we add 3 numbers together, it doesn't matter which 2 we add first. So if we're adding a plus b plus c, we can add a plus b first. And that's what these parentheses mean. We're going to do that first. And then we'll add c. Or we can add b plus c first and then add a. How we group the numbers, or how the numbers are associated, does not change the final sum. To me, the hardest part of these two properties is remembering which one is order and which one is grouping. How I remember is that associative is about grouping, and how things are grouped is also known as how they are associated. So we can say that associated has to do with grouping. How things are grouped is how they are associated, so it's the associative property. And then simply put, the other one is commutative. And commutative is about order. So now we can take these two properties and rearrange the numbers to possibly make calculations easier. So let's try an example. So here we have the sum of 6 plus 16 plus 26 plus 36 plus 46. And we're going to add that to the sum of 4 plus 14 plus 24 plus 34 plus 44. Now we can use the same rules we've been using in the past. We'll start at the left side and we'll go 6 plus 16. And that's going to give us 22. And then we'll add the next number, which is 26. And we'll get 8 and 4. And then we will add 36. And we can continue this process. And this process is correct. If all your addition is correct, you will end up with the correct answer. You will correctly find the sum of these 10 numbers. But can we work smarter and not harder? So when I'm looking to reorder and regroup addition, I'm looking for multiples of 10 or multiples of 100 that I can create. Because it's easier to add 10 and 20 and 100 and 200 than it is to add things like 17 and 34. Can we form multiples of 10s and multiples of 100 from these? Well, I notice a lot of our numbers are ending with 6 and ending with 4. And 6 plus 4 is 10. So we can create some multiples of 10. 6 plus 4 is 10. 16 plus 14, well, that's going to give us 30. 26 plus 24, that's going to give us 50. But how about if we take the first number 6 and add it to the last number, 44. And we add those up. And then we take the second number, 16, and we add it to the second to the last number, 34. Well, now we have 50 plus 50. Does this pattern continue? Let's see, 26 plus 24. Well, that's another 50. And then we have 36 plus 14. Well, we got another 50. And then finally, 46 plus 4. And that's another 50. So now we have 50 plus 50 plus 50 plus 50 plus 50. And that'll give us 250. Again, this works because all we have is addition. If there were any other operations here, we could not as easily rearrange these terms. When there are other operations, we'll get into the order of operations with PEMDAS. But right now, we're looking solely at addition. Addition is the only operation present. Let's try another one. Let's sum all the integers from 1 to 10. So the integers from 1 to 10 are 1 plus 2 plus 3 plus 9 plus 10. And again, we can go 1 plus 2, and that gives us 3. And then we'll add 3. That gives us 6. And then we'll add 4, and that gives us 10. That will work, and we will get the correct solution. But can we work smarter and not harder? Can we group things? Can we form multiples of 10? Well, we already have 1. How about 1 plus 9? Well, 1 plus 9 is 10. I'm going to cross things. I'll put a little check above them. That way I know I've used them. And we'll do that math first. And then we can go 2 plus 8. Take care of that. And then we have 3 plus 7. Check. Check. And then we have 4 plus 6. Check. Check. And so now we have a 5 and a 10 kind of left over. So let's go plus 5 and plus 10. So 1 plus 9 is 10. 2 plus 8 is 10. 3 plus 7 is 10. 4 plus 6 is 10. Plus 5 plus 10. So 10, 20, 30, 40, 50, and then 55. Summing all the integers from 1 to 10 is not that bad. It's only 10 numbers. But how about if you were summing all the integers from 1 to 50? Or 1 to 100? Another property of addition is the additive inverse. The additive inverse of a number n, is the number that is added to n to get 0. It's also called the negation of n, or the opposite of n. And we talked about opposites in the last lesson. So if we have n, its additive inverse, or its opposite, is negative n. If we start with negative n, its additive inverse, or opposite, would be n. So let's find a few. Let's find the additive inverse of these 4 terms. So we have negative 13. The additive inverse of negative 13 is 13. Negative 13 plus 13 is equal to 0. Now we have 5 pi. Remember, pi is an irrational number. But all these properties work with all of the real numbers, and pi is a real number. The additive inverse of 5 pi is negative 5 pi. So 5 pi plus a negative 5 pi is equal to 0. It also works when we're talking about variables. Again, x is a number. It's just an unknown number. And so if x is a real number, we can find its additive inverse. The additive inverse of 2x is negative 2x. 2x plus negative 2x is equal to 0. And then finally, we have a fraction. We have a rational number. And once again, the additive inverse of negative 3/7 is positive 3/7. Negative 3/7 plus 3/7 is equal to 0. Next, we'll look at the identity property of addition. When the number 0 is added to a given number, the sum is equal to the given number. So we called 0 the additive identity. So a plus 0 is a. And again, the order doesn't matter. So 0 plus a is also a. 3 plus 0 is 3. When we add 0 to something, what we added it to does not change. So we added 0 to 3, and we get 3. So let's find these sums. So we have 0 plus a negative 16. The result, the sum, is negative 16. Again, we can add negative 113 plus 57, get a number, and then add 113 to that. But can we regroup this and make our calculation easier? Well, yeah, we can reorder this and say 113, negative 113 plus 113 plus 57. And we'll do this calculation first. Well, that's the additive inverse. Those are opposites of each other, so that's 0 plus 57. And so the answer is 57. So now let's sum all the integers from negative 10 to 10. Let's start by writing these out. Negative 10 plus negative 9. Again, we can use standard rules of addition to add these. We'd have negative 10 plus negative 9. That gives us negative 19. And then we'd add negative 8. That would give us negative 27. And then we'd add negative 7. And we can continue this process. And this will, if all of our addition steps are done correctly, lead us to the correct answer. These rules of math, these rules of addition, will work. However, can we work smarter and not harder? If you notice, we have a lot of pairs. We have a negative 10. We have a positive 10. We have a positive 9, and we have a negative 9. So we have opposites, pairs of opposites. Can we reorder and regroup? Use those associative and commutative properties to simplify our math. Well, let's start grouping things. So we have negative 10 plus 10. And we have so many numbers that I'm going to start crossing out the numbers that I use. And then we have negative 9 plus 9. So as I went through this and reordered and regrouped, I crossed out each number as I used it to make sure I didn't miss any numbers or try to use a number twice. So now we have a lot of negative 10 plus 10, negative 9 plus 9. We have the sum of opposites. And the sum of opposites is 0. So negative 10 plus 10 is 0, plus negative 9 plus 9 is 0, plus. So all of our pairs of opposites became 0. And then we had a little 0 at the end as well. Well, now we're dealing with the additive identity. We're adding 0 to a bunch of things. Anytime we add 0 to something, Whatever the original number was comes right back out. And that includes 0. So 0 plus 0 is 0. So the sum of all the integers from negative 10 to 10 is 0. In this problem, we used all 4 of those properties we just talked about. We reordered and rearranged using commutative and associative properties. We then looked at additive inverses and found those pairs, added those opposite numbers to get 0. And then we added the additive identity, resulting in a sum of 0. The last property we're going to look at today is closure. A set is closed or has closure under a given operation if the result of performing that operation on any 2 elements of the set is also an element of that set. We talked about closure when we talked in our first lesson about sets. Which one of these number sets is not closed under addition? So that means when I add any 2 numbers from that set, the result will not be a number in that set. Provide a counterexample. And just to let you know, the remaining 4 sets are all closed under addition. We previously looked at the natural numbers. So these are the 1, 2, 3, 4, onwards to infinity. So any 2 natural numbers we add, so 2 plus 4, well, that's equal to 6. That's a natural number. Any 2 natural numbers that are added together will result in a natural number. So this is closed under addition. Now I asked for a counterexample. We've actually seen a counterexample already in today's lesson. A few slides back, I asked you to find additive inverses for some numbers. And one of those numbers was 5 pi. Pi is an irrational number. And we add another irrational number, in this case it's additive inverse, negative 5 pi. What do we get? When we add 2 opposites, the result is 0. 0 is a whole number. That's a whole number. It's also an integer, it's also a rational number. The one thing it is not an irrational number. So irrational numbers are not closed under addition. So another example, if I add radical 2 to its additive inverse, so negative radical 2, that will also give us 0. And these are not irrational numbers. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 6 problems. So here are our additive inverses for these 4 problems. For negative 5, it's 5. 22.3 is negative 22.3. Negative 7x, the additive inverse is 7x. And 2/3, the additive inverse is negative 2/3. If we add any of these pairs together, the result is 0. Now we're going to find the sum without using a calculator. And we're looking for ways to regroup and reorder these numbers. Now for this first one, there may be a number of ways we can regroup this to make solving it easier. But what I saw is a 101 and a 119. And that adds up to 220. As does 103 and 117. And 105 and 115, 107 and 113, and 109 and 111. So we have 5 pairs that all add up to 220. And then when we do 220, either 220 times 5 or add 220 5 times, the answer is going to be 1100. Now with this last problem, right next to each other, I see a 110 and a 90. Well, that's 200. And then I see a 175 and a 25. Well, those combine to form another 200. And then what's left over? 147 and 153. They also sum up nicely to 300. So 200 plus 200 plus 300 is 700. Keep practicing working with the addition properties of real numbers, and I'll see you in the next video.